Right, welcome back. MECH2320. We're getting into chapter 2. I'm going to go over symbols and schematic diagrams. A lot of this is going to be review from a lot of things that we've done over the course through electrical, digital electronics, PLCs, those sort of things. Alright, so we should be familiar with a lot of these symbols. Alright, so we're going to discuss symbols. Make sure that you understand. We're going to go over more of the NEMA. We'll still cover the IEC symbols, but we're going to cover more of the NEMA symbols and make sure that you know those IEC, just as good, and be able to go back and forth. It kind of just depends on the company that you're working for, which you're going to prefer, or if you're doing a foreign entity, you're going to use IEC. If you're going to use something, domestic, more of a NEMA type thing. All right, and I want you to make sure that we're truly understanding, normally open, normally closed, and what it means to be handheld open, handheld closed. All right, we should be able to draw all the symbols out as well. We will take an extensive test on symbols as well. Okay, most common button, right? Push button. That's what we use for control schematics. We look at the 870 trainer that we've been on. All right, multiple push buttons going on there. We push to open or push to close. Okay, so push to open would be like your stop button. All right, because it's normally wired closed, we would push to close. All right, or push to open, sorry. And then our start button back there is, push to close, so that we can put everything in auto. So we can take a look at them and understand what they look like if we have a normally closed push button or a normally open push button. All right, we also have double acting push buttons, very common as well. So they have double contacts. All right, so when they're double acting, we're controlling, potentially two different things at once when we are able to do that. Okay, so if we take a look at a normally open push button, this is the schematic symbol that we need to know for it. All right, it shows the two stationary contacts and it has the movable contact. So that's literally the button, that we push as we depress that. And notice that it's shown normally open because we have to press it in order to close the contactor. Okay, on the right hand side we have the normally closed push button. Notice that it's drawn under the stationary contacts to show that it is already closed, so that when we push on it, when we actuate the movable contact, it actually opens the circuit. Alright, so when it's normally closed, that would be more like your stop button. Okay, it's wired normally closed, and we would press it, to open it, right? E-stop, we want to shut everything down, so they're going to be normally closed. Okay, I'm going to step back just real quick. I'm going to come back to this slide. There's also different kinds of push buttons. There's mushroom push buttons and things like that, where they balloon up. The E-stop is considered more of a mushroom push button as well, because it'll have an arc over the top of the symbol, alright, and it has more of like a handle type scenario that we have on it as well. Okay, so let's talk about different switch symbols that we can use. Alright, we are very familiar with it. It's after PLC class and things like that. Normally open, normally closed. We're getting used to those, as switches, contactors, all those different things. The slight difference for us is normally open, held, closed, held, open type scenarios. Okay, if we take a look at a normal switch here, a single pole, single throw switch. Okay, we talked about these type of switches in the electrical class as well. So a normally open switch looks like the diagram on the left. Okay, we have two stationary contactors and we have the movable contactor in between. Okay, so that's our normally open switch, the most basic switch that we've been working with since you joined the mechatronics program. Okay, and then we have the normally closed switch. So hopefully we see that we can see the difference between it being open and being closed. We've seen those enough to understand those are the basic switches and how they operate. What's slightly new to us, is going to be the normally held closed switch and normally held open switch. Alright, make sure that you draw these along with the other ones so that you can see the difference between where the normally held closed. Okay, so let's look at the diagram on the left. Notice with the normally held closed, the movable contact is shown underneath the stationary contact. That means that it's held closed. Versus, I'm going to step back a slide here. On the right hand side, A normally closed switch, okay, the movable contact is shown on top of the stationary contact. Okay, so that's the difference between the two. All right, let's look at the diagram on the right here, the symbol on the right. That's a normally held open switch. Okay, so now the movable contact is pushed away from the stationary contact. Notice the difference. I'm going to step back a slide here, and we look at the normally open switch. Okay, normally open switch is on the bottom with the movable contact, and if we go back to the normally closed held open switch, all right, the movable contact is depressed up. Okay, so really those are kind of the differences between, you know, understanding our basic single pole single throw switch. Okay, all right, let's talk about where switches happen. Okay, to us these are sensors essentially, but they're switches as well. So we have a thermostat, right? What does a thermostat do? We're taking temperature, reading temperature, right? We did a lot of talk about the thermistor in the Wheatstone Bridge in the electrical course, right? In 1310, we really got extensive in that. We understood what V out did and how that change in voltage was created by a change in the resistor value, which was a special resistor called a thermistor, right? That detected ambient temperature, and its resistivity changed based on that, and we were able to change the output voltage. Okay, so thermostat, that's really what we're doing. We are taking readings of, you know, temperature. All right, next we have a pressure switch. Okay, pressure sensor, pressure switch, same kind of thing, right? Because it has to do with, you know, opening and closing based on a specific amount of pressure in the line. Okay, and then if you take a look, all right, the low pressure switch and the high pressure switch, those are, look at the difference between kind of the symbols and how they are. So low pressure, okay, it's closed on the bottom. High pressure, closed on the top of that scenario. Okay, and then the thermostat, right, that one's open. So what we really do, you know, if we just take a look at the system here, if the system pressure drops below a certain value, the normally open held closed low pressure switch opens and de-energizes the coil. So that's really kind of how we want to make sure that we understand what's going on here. Okay, so understanding the different switches and how we put them into play. All right, so basic schematics. Okay, we've done a lot of this through digital electronics, you know, understanding, you know, when we were making series and parallel connections in the electrical class. Okay, that's still a basic kind of schematic, being able to determine, you know, what's going on in each one of those. Okay, so basic schematics. So what are we showing there? We're showing components in their electrical sequence. Okay, it's not showing where they're physically located on a plan diagram or anything like that, but it's showing where they are in sequence. Okay, and they are always designed to show components in their de-energized state, meaning as it sits with everything off, nothing's been started. Okay, and then what we need to know is any contact that has the same label or number as a coil is controlled by that coil. Okay, we learned a lot of that more in the PLC class. All right, even if we used a memory coil or a timer or a counter, those sort of things. Okay, or a specific motor, right? We gave a motor a coil tag, and then we could use that as a normally open, normally closed contactor to start something else or turn on a light or those sort of things. So why is that important? Because of the last bullet point here. When a coil energizes, all contacts controlled by it change position. Okay, so very, very important there when we do that. Make sure that we understand that. Okay, so let's take a look at this diagram here. What's really going on here? Okay, so we have our hot neutral lines, okay, on the left and right hand side. We have a float switch. Remember, what's a float switch do? Okay, we're measuring the level in a tank. All right, so there's a float switch. Okay, and then we have a normally closed contact that goes to the control relay coil. So the control relay, the normally closed switch right before the buzzer, that's controlled by the control relay down below at the bottom of the line. Okay, or the rung if we were to call this ladder logic, right? So remember, we're doing a schematic here, and a schematic is how we are hardwired in the field. So it's slightly different than the ladder logic rung or things like that. But we can see, all right, how the control relay coil at the bottom is still being operated by those contactors and that buzzer, all right, and how the light is turned on. And then we can press the button, the push button, manually. Okay, so this is just a gist, just an overview, guys, of what we're doing. I still want you to make sure that you read through the book. There's a lot more in this chapter to understanding basic schematics and things like that than just what we're going to talk about in the lecture. I really want you in this class to really focus on, we're going to be doing a lot of wiring. And I think once you start wiring, that's when you can start truly understanding how to interpret schematics and things like that. So just remember, I'm not going to get into tons of detail in this lecture. You know, we've talked about a lot of these sensors throughout, you know, all the courses. I really want us to get into the meat and potatoes here soon. I really want you guys to be wire things up and literally make motors run and that sort of thing. Okay, so what we want to talk about, sensing devices. Okay, limit switches, float switches, right? Float switches, we've just talked about them, right? We're detecting what's going on in a tank. What level is the fluid in the tank sitting at? Pressure switch, right? How much pressure is in a line? It could be pneumatic, it could be hydraulic. Flow switch, you know, how much flow, all right, gallons per minute, liters per minute is going through that line. Temperature switches, right? We're using that thermistor to detect the ambient temperature or the temperature of whatever we're working on to make things open and close when we reach certain temperatures. Okay, so very, very important there. Okay, coils, those are our output coils. And we're talking coils, right? We're talking about contactors or things like that, or where we're, you know, sending current through, making something open and close. You know, whether we're using motor contacts that we're going to get into, or solenoid valves, or those sort of things. You know, output devices and how we make them work. Time contacts, contact symbols, other symbols. We need to make sure that we understand all of those, you know, as we go through it. And I think, you know, with the PLC class, we're really starting to hone us in here, okay? So we've gone over limit switches extensively, all right, and we talked about them a lot in the mechanical class, all right? So in 1320, you know, we did a whole different section on limit switches, and we know that they're on station 2 on the 870 trainer, okay? So we know the two symbols, right, for the normally closed limit switch and the normally open limit switch, okay? It's got the little red dangly kind of triangle piece on it, right? That's to simulate or to kind of signify that it has that little mechanical arm, right? Because remember, a limit switch takes a mechanical signal and makes an electrical signal because we push on that little arm. All right, the only differences for us is if we have a normally closed held open limit switch and a normally open held closed limit switch. Okay, so you can kind of see the difference between the two schematically. Okay, so I really want you guys to focus on making sure that you write down all the schematics that we see in this chapter. Okay, you will have a big test on these. We had a test on these in PLCs. We have tests on these in fluid power and all those sort of things. You really need to know and understand these. We have to understand the flow of how everything works, whether it's, you know, fluid power, mechanical power, whether it's electrical. Okay, we need to understand all these different things. So you need to understand what the float switch symbols look like, whether it's normally open or normally closed. Okay, what the flow switches look like. Okay, it's got the little flag on it. Okay, so know the differences. The majority of these, right, all have the two contactors that are shown. Okay, but we need to understand, you know, what a normally open, normally closed pressure switch looks like, temperature switch looks like. We should understand what we're really talking about by now when we're talking about flow, pressure, temperature, those sort of things. All right, a lot of common sense by now. Okay, the last thing, right, we got a proximity switch. Remember, what's a proximity switch? Well, think of all the different sensors that we have on the 870 trainer, all right, reed switches, things like that. They detect the proximity generally of a magnetic field, right? We have, you know, those Hall sensors or reed switches or the proximity switches that are sitting on the cylinders on the 870 trainer. So we use those to detect whether the cylinder has extended or retracted. So it's detecting where the plunger is inside the cylinder. Okay, so just so you kind of know, that's what a proximity switch is. We've talked about them a lot, but that's really the symbol that's going to show up on a schematic for us. Okay, other symbols that we need to know. We've gone over these before in the PLC class and the electrical class. So like I said, This section is talking about a lot of symbols, but a lot of review. Okay, so if we have that circle, right, that's generally used to, represent a coil, right? In a line of ladder logic, it's the output sort of thing. For us, can also represent motor, right? If we put an M in it, we're going to have motor. Things like that. All right, the little heart pulse sort of thing, right? That's our solenoid coil. So remember, the solenoid is generated. We put current through a coil of wire, creates a magnetic field. So the solenoid's going to either extend or retract a plunger. And we use those on every single station on the 870 trainer, all right, because every single directional control valve back there has a solenoid valve on it that allows for air to flow one way or another to actuate things in the system. Okay. Then we have an iron core inductor. Notice it's what makes it a transformer is if we put the inductor on both sides of what's going on. Okay, so remember, that inductors really kind of are transformers and vice versa. They're not 100% that, so don't quote me on that, okay? But I want to explain the difference. Remember, a transformer, okay, we are inducing voltage from one side to the other based on the number of coils of wire we have, right? We had a step up or a step down transformer or an isolation transformer, to help filter signals. So what did that do? Remember, those were not ever wired together. We induced it using magnetic fields. Okay? An inductor, we didn't really talk about much in the electrical class. If you had me, we talked about inductors, but we didn't do tons of work with inductors. Okay? Remember how capacitors store a charge. An inductor stores a field. Okay? Essentially. That's really what we're doing, because an inductor is a coil of wire. So we're storing a field. And we use that field to help filter signals and things like that. So we use, RLC circuits, resistor, capacitor, inductor circuits, to help filter different things. Your stereo uses it, right? You want to filter out a certain radio frequency or things like that. So we use them to clean things up. All right, so the two bars on the iron core inductor, that's symbolizing that it's iron. So if you remember, the iron core transformer looked almost just like that, only it had the little squiggly inductor piece on both sides of it. Okay, same with the air core inductor. All right, it's just those little bubbly, squiggly, whatever you want to call them, cloud tops, things like that. So that's the air core inductor. Remember, the air core transformer had those on both sides. So if we have an air core inductor transformer, I still want you to remember we did Tesla coils and things like that. So I really think that was more of an air core inductor, right? We didn't use any iron to wrap it around. We put it around PVC. So that was still like an air core when we wrap a coil of wire around something like that. Okay? So it's not around something. It's literally around air. Okay? So just make sure that we understand, all these symbols and what they mean. So when we start wiring things up, I want you to understand, why this is connected to this. And what is this? I'm going to give you a schematic and ask you to wire something up potentially without any directions. Now that'll happen later on in the course because you're going to do the labs so that you should understand what those schematics are. But I might give you that trainer and be like, all right, go wire that up so the motor runs. All right? Very simple, but yet, you've got to be able to go through the lab so you understand where the connections are made on what terminals and that sort of thing. You can't do that yet. Some of you might that have already worked in the field or something, but for the most part, all right. After this class, we should be able to wire a bunch of things up, not be afraid to wire stuff up, and we should be making, all these different components work. Okay? Now, we also have, what we learned about in PLCs. All right? You have counters and timers and that sort of thing. So make sure that we know the symbols for that. So we have an on delay timer, okay? So normally open and normally closed on delay, and a normally open and normally closed off delay. So if we remember, an on delay timer is where we energize the circuit, and let's say we told it to wait for 10 seconds. So what'll happen is we close the switch, okay, and then the timer starts counting. And once it reaches 10, then it turns on what we told it to. Okay, so that's kind of how that works. Remember, an off delay timer means the second we disconnect it from power, that's when the timer starts to count down, and we still get power, and then it shuts off after 10 seconds if we told it 10 seconds. Remember, that's the one where we talked about the dome light in your car at night, right? When you get out of your car, all right, you take the key out of the ignition, you open your car door, and then you close your car door. Your dome light generally still stays on, right? And then it fades out after 10 seconds. So that's an off delay, right? You close the door, that disconnects kind of the power piece to it. The timer's counting down, and then after 10 seconds, it turns it off, okay? So we've talked about that in PLCs. We've done different timers, right? You guys did the stop lights and everything like that, but you still need to know the symbols, okay? So just remember, the offs have the arrows, and the ons, it's kind of like the arrows going into it. Okay, and then, contactors. We should know this from PLC class. It's like that. They look like capacitor symbols, but they're not 100% capacitor symbols, right? They're contact symbols for us. So we have normally open contactors, and then we have normally closed contactors. Remember, they're closed with the line slash through them. So very, very important, guys, that we understand all these symbols. And I think we understand the normally open, normally closed contactors because, we did a lot of programming in the PLC class. So you should those should make sense to you. Okay, so I just want you to know this lecture doesn't cover everything. I want you to still read the book. Make sure that you understand some things. It might clear some things up as well. Alright, but it's just to kind of, let's talk through this. A lot of this stuff's review, but I want to make sure that we solidify, what we're doing here. Else, guys, like I said, email me with questions, or let me know if we need a team meet or Zoom meet. Else, have a great day. I will see you in class.